Hi everyone, I'm Martin and welcome to another great edition for astronomy for beginners. Now today I'm going to do a DIY guide on making a Newtonian primary mirror cooler. Now it's really quite easy to make, and as you can see here at the primary mirror, it is quite professionally made. I mean, it looks as if it's part of the actual telescope setup. Now the good thing about this cooler is what it does is as you take the telescope outside, what you're trying to do is you're trying to cool down the mirror, so you're going to maximize the optics. Now all the heat waves and anything that's trapped inside the tube will affect your views, and the whole idea is with this fan, it will speed up the cooling times as well as maximizing and stabilizing your views. Now this will help to speed up the cooling times of your mirror, and so you can get all the detail that you can see on the planets and the moon. It's very crucial that you cool down that mirror. Now, as you can see, it is very important that you do that, because if you don't let it cool down, what you'll probably get is you'll get stars and your planets will start to shimmer all the time, and you just can't see all these hidden detail. Now the good thing about the cooler is that it will help to speed it up, and once it gets to that certain temperature, around the ambient temperature, you'll be able to see the detail a lot better, it'll be a lot more sharper. Now the bad thing about this design is that I'm not going to guarantee, the thing about this cooler, it's not going to guarantee your actual views, because it all depends on the Earth's atmosphere as well. So again, it will reduce the shimmering effect, but if the Earth's atmosphere is unsteady, and it's very really bad, it's not going to improve it so much more. Okay, so you're always going to get some kind of turbulence in the Earth's atmosphere. However, when you do have those certain nights when they are steady, alright, this way it plays big time. Okay, what you're trying to do is trying to cool it down, and the good thing about this design that I made is that you can still run the fan and still keep cooling the mirror. And the good thing is it's easy to make. You can make this for around about £30. You may find different parts to be able to make it, but what I'm going to do is I'm going to show you how to make it. And the good thing about this design is you can power it off with a cigarette lighter, okay, like this, or you can plug it in by USB, okay, and it runs off with just 1 amp of power. I don't need a lot of power. And the good thing is you switch it on, and it's a low vibration fan, alright, so you're not going to get any of the vibrations that you're going to see in your mirror. Alright, so anything that's jerky movements and all that, this will minimize that. And the good thing is it has a built-in speed controller, so I can actually slow down the pace of the fan. Okay, so it's quite easy to make. Okay, anyone can make this at a good price. Okay, and you can make this for £30. Alright, and I'll show you how to do that. Okay, step-by-step guide, guaranteed to work. Okay, if you follow the guide, you're going to get a good Newtonian cooler for the money. Alright, I mean £30, or if you can get it a little cheaper, you've got a device, a cool device that will not only cool but also help to improve your views on a Newtonian telescope. So again, the cooler works fantastic, alright, and it's pretty smart, okay, and it just velcros apart like so. Okay, so as you can see, and the good thing about this Newtonian cooler, I can still be able to do my collimation where it's designed. Okay, and the good thing is because it's got a PERPEX sheet here, it also acts like a good light shroud. In other words, it'll stop any stray light from entering the primary mirror. Okay, so again, you can make one yourself. All right, feel free to make this yourself. All right, and what we're going to do is we're going to take a closer look on the tools and equipment you're going to need to make this device, and then follow the step-by-step guide. I'll show you the process, how to make it, and then so you can do it yourself. And believe me, it's worth every penny, and you can really tell the difference in your images. It makes so much a difference. We'll take a close look from here. So I'm going to show you the parts first so you can make your Newtonian mirror cooler, and here are the following. First off, you're going to need 3mm PERPEX plastic sheeting. Now you can get these from a lot of DIY stores, and you're going to use, because this Newtonian mirror cooler can be used as a light shroud, so using a dark colour PERPEX plastic sheet like this, which is A3, depending on the size of your mirror you may need to go and get bigger sheets. Now this will fit a 8" to about 9" of mirror, so you can cut the material. Depending on the size of the sheet, the more expensive it's going to be. And believe it or not, this is actually the most expensive item actually in the actual list itself. This cost me around about £5.99. PERPEX is not usually as cheap as I like to be, but the good thing is, buying one that's already with a plain sheet, it's going to be the cheaper option. However, you can buy a PERPEX sheet already cut to your size. So if you go and click online on this link here, it will direct you to a plastics PERPEX company, which you can actually get pre-cut items of your choice. So basically they can cut this to the exact size you want, and it will reduce the need for having to use power tools and all that, because believe me, cutting this 3mm PERPEX can be a bit difficult sometimes, and if you don't have the tools to do it, you can't measure it up and do all the things you need to do. Okay, do expect to pay a little bit more if you're going to have it pre-cut, because if they cut the perfect circle diameter that you need, you're going to make sure that the size is correct, and expect to pay a lot more money. Now I've did a quote, and they quoted me around about £8.99. However, I'm actually going to cut this myself because I've got the tools to do it, which I will show you the tools you're going to need to do it. So advise, if you've got the power tools to cut a perfect circle, then brilliant. However, if you don't, then I advise you to click on that link, which will direct you to there and give you a pre-cut circle PERPEX sheet. Okay, but again, search on eBay or Amazon. There may be some sizes that will fit your telescope diameter of your mirror. So I've decided to go on the cheaper option and do it myself, because I'm very good with power tools and all that. So I'm going to show you later on how to measure this up, how to get the exact diameter circle you need, and find out the dead center of this sheet. But again, this is the most expensive part of your modification. Next part you're going to need is one of these. Depending on your size of mirror, I've gone for the 92mm cooling fan, which is basically a computer cooler for a hard drive. This is 12 volts and it's a 3-point connection. Okay, it's a 3-point connection, and you don't need a high powered fan either. This will go to about 1900 RPMs. Now the reason why I don't want a high powered fan is I want to cool the air in the tube first. I don't want to dramatically just massively cool it and may risk freezing up the primary mirror. Okay, so I only want some mild cooling. You don't need a high revolution fan to do this. The reason why it's got a 3-point connection is, as I'll show you the next component. Now you can do this modification without any accessories. You can have it directly for a direct feed onto your modification. However, I wanted to install a speed controller set, and again, this is the reason why I wanted a 3-pin fan, is because this will control the speed rate of my fan unit. And again, looking through Amazon or going to eBay, you can pick one of these up for about £3, maybe £6, and basically this is to set the speed of your fan. So I'm going to install a speed controller fan, so I can set different speeds to suit my taste. You don't have to buy this item, you can cut down the cost a little bit more without installing it, but the one thing is you won't be able to control the rate of the fan. Alright, but I think just for a little bit extra money to install this within your project is well worth getting a speed controller fan. Now with the 92mm fan, I ordered the 92mm fan guard as well. So for the sake of £2, okay, it's well worth just investing in one of these. Okay, it will protect the fan and stops you getting your fingers getting caught as well. Okay, so again, you don't have to buy this item, but again, to cut costs low, if you don't have the option, then you don't have to go for it. But personally, it's well worth a little extra for that. And the next thing in line is, with all the wiring involved, I just bought myself a little project electronics box, 60mm by 36 in width, 60mm in length, and 25 in height. Okay, this is just a little perspex box. Okay, I just want to keep all my cables nice and tidy, and it's all sealed up. Okay, you don't have to do it, you don't have to invest in this to cut costs low, to keep the costs down low. Alright, you don't have to get it, but I thought it was an idea to just install a project box so it keeps all the cables nice and tidy. Now with the electronics involved, you're also going to require one of these. Now this is a USB converter. Okay, it's got a male end and it's got a 3-pin connection. Now basically what this is a USB 2 connector, input of 5 volts, okay, with around about maximum of 400 milliamps. Alright, so you don't need a lot of current for this. This will enable you to connect your USB via a computer, or you can connect it with a cigarette lighter adapter, which I'll show you later on. Okay, you connect that directly, so you connect that to a power tank or computer, and what this will enable you to do is connect directly onto your fan unit. Okay, the good thing about this adaptation, that this will maintain the fan unit to maximum speed, so it's not going to reduce the fan speed. Alright, I don't want to reduce that. Now also, because it's 3-pin, combine that with the speed controller, I'm going to make sure that the speed controller will be able to control the rate of the speed on there. Alright, so it's a 3-pin adapter. Alright, and it will fit onto the fan unit if I want it direct feed from there. Okay, it's up to you, but I want to install the USB connection, so I can either connect it to my computer while I'm imaging, or I can connect this into my power tank. Alright, this is an expensive item. I've seen this for £13. However, if you shop around, you may be able to get one of these for about £4, maybe £6. But again, it's only 0.5 meter long, it's not too long. Alright, and it's perfect. Okay, so again, if you can find one of these, go and get one by all means. With the adaptation, I want to extend my cables. So this is a 3-meter male and female USB 2 cabling, and again I want to extend my cable. This only cost me around £1.90. And like always, you're gonna need like screws to mount the fan and my box. Okay, you only need a few of these. Okay, I've already got the screws to set my fan guards, so these are like for my fan guards, but these ones here are number 4 posi drive, 1/2 inch long or 2.8mm in diameter in thread, and 30mm long screws. Okay, they're only tiny little screws. You know, you only need 10 of these depending on your project. Okay, I only want 4 to mount the fan and 2 to mount my little cabling. Okay, my cabling box installed. So you don't need much. These screws here are basically what I got with the fan unit. Okay, I got those, they're different screws. And also you're going to need double-sided Velcro straps. So you're going to have these are just basically you can attach. This is a meter long. These are 20mm thick, and then this is a meter long Velcro straps. Okay, so you're going to need some of them. And final component you're going to need is this 2.1 or 1 amp USB charger, and you can connect that to a cigarette lighter in your car or a power tank, depending on what power application you use. The good thing is the voltage is regulated. Alright, I don't want to withdraw too much wattage, alright, especially for the fan unit. Plus I don't want to risk blowing the fan unit itself. Okay, this is fused. Okay, so depending on what applications, 2.1 amp or 1 amp. You can pick these up for a couple of quid. That's how cheap they are. There's loads of these you can pick around eBay or Amazon. Just have a look from there. Right, see if you can just pick one of the size. But the one thing, the size I picked for is the 5 volt, and this is the 1 amp. Okay, I wanted the 1 amp because basically I just want to run the actual fan unit on just 1 amps. Right, not too much power, and I don't want to go through batteries like hell on earth. Okay, the good thing about this will work with a input of 12 volts. Okay, so make sure you get one that works with 12 volts. Alright, don't get the 24, alright, just get the 12 volt one. So get yourself one of those. Right? And this project is designed for the Skywatcher 200mm Quattro. So this is just a baseline or guideline on how you will do your reflector or Newtonian telescope. You need to check the size of your scope, the diameter of your primary mirror cell. Your sizes will differ and prices will also differ. So again, check the sizes, order the parts. And the electrical components are exactly the same. Alright, there's no difference. The electric components that I've described to you are exactly the same. You don't need to do anything else. Alright, everything's all worked out. All you need to do is get the correct size of the fan, especially the fan, because again, you don't want a big fan for a small Newtonian reflector. Okay, so for example, if you had 150mm Dobsonian or Newtonian reflector, then you probably need a 60mm fan. Okay, so you don't need a big fan, but that just depends on how much you want to spend and how much you want to use on material. But again, a 60mm fan for a typical 150mm is probably more than enough. So the tools you're going to need to do this job are as follows. First off, you're going to need some kind of permanent marker pen to mark out what you're going to use. Okay, depending on the screws, you need posi drive screwdrivers, a number 4 or a number 1, depending on your screws you're going to use. Okay, on your project, so you're going to need screwdrivers to do this job. Also, a tape measure. This will become apparent later as I describe through the video. Again, measuring out what you need to measure the primary mirror. Now if you've got a set of vernier calipers and they're long enough, they're much more accurate and you can measure the diameter of your telescope mirror. Okay, so again, some kind of measuring device, and tape measure will do the job. It will give you a rough sort of closest damn it. A set of marking tools. Now you can buy one of these Helix mathematical kit. Okay, again, these are just to find out your measurements. Okay, when you're marking out or cutting stuff. Right, you can buy this little set for about a couple of quid. Right, it's not a lot of money. Okay, something that you can mark doing your cutting of your plastic, perspex plastic. Okay, and again, you need something like that. Now, you may want to use power tools to do the job, because if you've got a sheet that requires cutting, you're going to need an electric drill, and the one that you're going to try and cut circles with. So you're going to need a circle cutter. Depending on the diameter of your mirror, it may be a bit tricky. Personally, you can get these adjustable circle cutters. They do the job. They do work if you've got a steady hand, but I find out that they're a bit dangerous to use. Power drills are good when you get circle cutters from small diameters, from 30mm all the way up to say like 4-inch diameter. You can get big circle cutters. Alright, they're okay, they're quite accurate. Again, we're only cutting through 3mm perspex plastic. Again, this is why I stress enough, if you don't have tools to do this, then you need to just get pre-cut plastic circles and go to that link there to get to order one. However, if you're an owner of a Dremel like this one, like I've got here, this is my rechargeable Dremel, and basically I have a 2mm spiral milling tool. Okay, this is a special drill bit, and what this will enable to do is cut circles along plastic sheets or metal or wood components. Okay, this has a special device which is like a bit like a compass in a way, and basically you have a fulcrum point here. You adjust your settings, okay, the size, the diameter. Now obviously this is already set to my circle that I'm going to cut. Okay, and basically what I do is when I put it on a piece on my perspex, for example, once I get my circle aligned, I basically plonk my circle on there, and then as I'm cutting, okay, this also, if I adjust the feed gauge here, like so, okay, basically I can just cut around, all the way around, like so, okay, bit like a compass, but I'm cutting the actual material. This is actually quite a useful tool. Some people don't really like using it, but I've managed to cut my circle with it, so without any hassle. However, before you start cutting, you need to start marking out your sheet first, because you don't want to make a mistake on this perspex sheet, because it's quite expensive. So you're going to need something like this, and again, this you can pick these up for about 20 quid for the attachment. Okay, the drill bits cost around about 5 quid for a set of 3. Alright, and you can just use this device. It's really handy little tool. And you can cut diameters as big as 10-inch all the way down to 2 centimeter circles. So it is well worth the actual money for it. Okay, these are special drills. These are designed to mill. They're a milling drill bit. You can't use normal drill bits. And of course, if you don't have this this Dremel and you don't have the attachment, you can use a jigsaw to cut all the way around the circle. However, this is very tricky, and also with the jigsaw you're going to make sure that as well as your circle needs to be perfectly round, you're going to be careful that you cut it with the correct cutting blade for your jigsaw. Or if you have a router, that's even better. If you've got a router, you can do this job quite easily. But again, if you don't have the tools to do it, just order the pre-cut ones. Alright. However, even with the pre-cut ones, you're still going to require to cut a circle in the middle. Okay, and now that becomes apparent later on. So you're going to need depending on the size of the fan, okay, the size of that fan, depending on how big the circle wants to be. Okay, for this one, I can get away with cutting a circle of 90mm or 92mm. It doesn't matter if you slightly overlap either side, as long as you've got a circle, as long as you've got some bits, holes, enough space so you can drill the holes to mount it on. So what we have here, I've just tilted my Newtonian, my 8" Quattro, upside down. So basically I have the secondary mirror facing down the tube, okay, and this is back of the primary mirror itself. Now, as you can see, depending on your reflector, this one has no mounting spider frame. Usually you get some reflectors that have like a metal attachment in the middle. Now, if you got one of those reflectors, usually on the 200p or those brands, as you notice, there'll be a mounting for a fan. Now, if you do have them, it means it's going to be even cheaper for you to mod that. And with all the screws in place, as long as you get, usually it's an M5 or M6 mounting screws, you can mount the fan directly on there. Okay. The disadvantage of that mod, as well as being cheaper to, it'd be cheaper to make in the long run because you don't need as much parts. But the one problem is though, this modification that I'm going to use is going to act like a light shroud. So because there's no mounting brackets here, it doesn't mean say it's a bad telescope or a bad design. Okay, not all telescopes have this function. The good thing about this is I'm going to make my my plastic Perspex circle, so it's going to fit over the top of this primary mirror. So what that does is it will cover and prevent any stray light getting in. So everything, all the electronics and everything on there will be actually on the Perspex plastic itself, and it's going to be like one unit. So it's going to be a pretty smart design. With this is, before you start cutting any Perspex material, make sure that what you need to do is measure across the diameter. Now, if you've got a set of vernier calipers long enough, you can measure from this inside circumference. Okay, so from this point here and this point here, okay, I can measure with a set of vernier calipers across, and gives me the inside diameter of that ridge. Okay, as you can see, this ridge here, alright, I want that to be mounted inside that ridge, so it's a nice good fixture. Unfortunately, I don't have a set of vernier calipers long enough to do that. Okay, I've only got 150mm length vernier calipers, and this is, I've just measured it across. There are ways to do it, and again, using the humble tape measure, you measure across, okay, like so. Okay, just measure it across bit by bit, and what I've got is around about 220. Now, I don't want it to be bang on 220. Okay, so I'm going to cut it slightly undersize, say like 215 for example, so it gives me enough space to fit it in there. As long as I get the rough size and I've got it so it's just enough so it mounts on this flat surface here with the Velcro pads. Okay, as long as it's covering the primary mirror and I've got no gaps, that's all I need. Okay, see, but one problem about this design with this reflector is once I cut the circle, I'm still not going to be able to mount it because I have my collimation screws. So I've got the lock screws and the collimation screws in the way of the primary mirror. So that means when I make my design, it means I have to cut a little slots, okay, in my circle. For the others people, you might not need to do that. You can just mount it over the top, okay, but that just depends on your design of your reflector. really does depend. And again, it just helps, you know, you just got to keep measuring. Oh, obviously, and I measured this one up, I need a minimum gap of about 2 inch. Okay, so I need 2 inch either way, or 50 millimeters across. Okay, and around about 20 millimeters or 2 centimeters sort of slit in depth. So I need a little bit of a gap so I can fit my circle in place. I've got those sizes down. Keep note of them because you're going to need this later on. And what you're going to do, once you've got those dimensions in your head, you're going to start marking the PERPEX. Now, using your, if you've got a set of these, because you don't have a circle to line, you can basically just use a set of compass, basic set of compass. Find out the circumference, okay, because mine here is 220. Okay, so I need to get my rule like so, measured from point to point. So because I don't want to go 220 in diameter, I need to go 107.5 millimeters. Okay, so I need to go 107, so I measure it up round about there. Okay, so that basically gives me my 250 millimeter circle. Okay, and I basically just go on there and just draw all the way around. So I've drawn my circle. Now usually, because it's PERPEX, if I use a compass, usually you get a marking bang on dead center. Unfortunately, because this material is so hard, I can't see the indentation from the compass. So you're thinking to yourself, well, what can I do? What can I get the dead center of that circle? Now there's a trick to this, and it's a simple one as well. Usually you can use an engineered square. However, this is too small, and basically you need to find out by marking from the dead corner, from corner to corner, to get the dead center. However, one simple trick, and this is a trick that I used many years ago, and it still works to this day, and it's the best thing I've ever used. And basically this trick is, get yourself a sheet of A4 paper, okay, like this. That's all you need, and usually the paper is usually dead center. Now this is a technique that I use to try and, on my Orion Optics reflector that I had a 10-inch reflector, and because the main problem is I didn't have a spotting collimation circle in the middle. The good thing about this technique is everyone's got an air sheet of paper. It needs to be that. What I do is grab yourself a pen, and what you're going to do, from this corner you're going to measure up bang on this corner. You then mark out the lines. So you mark out this line and that line, okay, that line and that line, okay, those are your points. And with those points, now I know I've got an engineered square, but I'm just going to use the paper. I'm going to trust the paper for this job. Okay, and what I'm going to do is I'm going to draw a straight edge like so, point to point across. Okay, that gives me my first marking on that circle. Then, trusting the paper again, because we worked out our markings, okay, like so, what we're going to do now is we're going to reverse it, okay, corner to corner. So all it takes from that point there, okay, from that point, do your markings from there and there. And then what you're going to do now is, with those markings, using a straight edge, line up the markings and draw across from there. Now you will have a dead center point here. Okay, that is very crucial while we do this, because then it'll give your, when you mount your fan, it'll mount dead center of that circle. Also, you need to cut the other circle inside there. So depending on the diameter of your fan, this is 92. So what I'm going to do with that 92 is I'm going to draw a circle inside here using my compass. Okay, and again, half of 92. Okay, I can do it at 90mm, so I can either do it at 45. So again, using my ruler, finding out my compass diameter, so 45, because it's 92, so I'm going to measure up to 46. So once I find out there's my 46, and line it up in the middle like so, and I'm going to draw my circle all the way around here. So I've now drawn my circle, and you can see here now, this is the place where the fan's going to go, and then I can mount my, so I can mount my screws on there in place. Unfortunately, I slightly overlapped, but it doesn't matter. Okay, what we're going to do now is we're going to cut that out using this tool. And again, because we've got our circle marked out, okay, we know the dead center, and we can just basically cut around, measure it up like so, getting the pin set up. Okay, so that's in line, and then you just quickly move it along to the cutting blade itself. Okay, the fulcrum's here at this point. Okay, so just because it looks slightly off, and then basically what I do is I switch her on, and then I'm just going to cut all the way around there and measure this again, and I'm going to cut all the way around this as well. Now after you've done that, here's one I made earlier, and as you can see, that's exactly what you want, a nice perfect disc with the hole cut in there. Now as you can see here, I've already measured using my dimensions, using my 50mm markings here. Okay, so my 50mm markings, and basically I've done it as 10mm for time being. Okay, so I don't want to take too much material off, even though it's 20mm. I only done it as just to 10 for time being. And again, using my Dremel, you may want to use a jigsaw, but again, as you're marking with the jigsaw, you need to try and drill the holes here at these corners first before you can jigsaw across to make these slits. Right, so that's basically, if you have to do that on your reflector, you're going to have to make some gaps there. Using a Dremel, I just use the milling tool. Okay, take that device out, and I'm just going to cut by hand using the Dremel with a steady hand, and I'm just going to cut these slots out like so. One thing to be aware of is I've already marked out my holes, and the easiest way to do that is I just get my fan like so, I line them up Okay, and I basically just get my pencil, okay, get my pencil or pen, one or two, and I just basically just mark up the holes. Alright, don't need to be perfect, but as long as I'm in line, okay, that's fine. Also, I've marked out my holes using my little component box that's going to place underneath here. So basically all my cables and all that, the cable tie and all that are going to be held in there. So I've already marked out my box from the inside. Again, these holes are 2 millimeters or 2.5 millimeters in diameter. So these are the only holes, and I basically just line them up, and I've got my holes already set. Okay, like so. Okay, we're back to my 8-inch quattro, and we're going to place this on top, and basically that's what's going to happen. Now, as you can see, this does not fit precise. Alright, doesn't matter about if it's, I just wanted a bit of play inside there, so I didn't want bang on 220. Alright, I just want it so it's loose, so I can peel it off. Okay, try and pull it out. But it's not crucial, as long as you've got the inside diameter and it can just fit inside, that's fine. As you can see, I've just milled out, using the Dremel, the slots. Now, as you can see from this picture, I've had to measure another extra 5mm in either side, because this does not fit precise. Okay, so I want this so that I'll be able to fit it and able to do the collimation. I've got to recut them. As I always said before, better to under measure than over measure, because if you overcut, it means you've wasted some PERPEX plastic and you're going to have to buy the new sheet and then start again. However, it's always best to do bit by bit when you're cutting. I was undersized, so I just need to recut some more parts here, as I just measured on there. Okay, so I'm just going to need to do some more milling. Okay, recut that, and hopefully it should fit. So we milled the extra bit, and what we should see is this. As you can see now, I've got it so it's slightly undersized, so I can just take it out. I don't want it to be too flush, okay, because it'd be a bit of a nightmare to try and pull it out. However, I'm still inside here. I can still mount this PERPEX plastic, and it gives me enough gap to be able for me to just do my collimation as well. So it's giving me plenty of room. Okay, and then that's the basic shell now, already made up. Using a 2.5mm or 2mm drill bit, using the drill or Dremel, and just mark down the holes, and the holes there for my little project box to put all my cable in. So that's what we have now. Looks impressive. We'll proceed to the next step. Bear in mind, different modifications, you know, you need to check the inside diameter. Okay, this is more than ample. We're basically going to peel off the plastic. Okay, peel it off. You don't want the outer coat of plastic. Now, as you can see here, I've got rough edges there, so what I'm going to do is I'm going to file these down, okay, before I start adding more stuff onto them, so they're not quite straight. So I'm going to file them down using a file. So I filed them down, and it's looking all nice and sweet. So basically I'm going to peel off the rest of the packaging. That's our basic plate we're going to put in, and now what we're going to do is, because we've got the holes already drilled, we're going to place the fan over it. Okay, so it doesn't matter where you want to place it. Okay, doesn't really matter. Alright, you can place this fan everywhere. Using a screwdriver, mount them on those holes. So what we're going to do is we're going to, making sure, one thing I need to point out, make sure that the fan is pointing down that way. Okay, because basically this fan system is designed to blow inwards. Okay, so I want the fan to withdraw the air out from the tube from the other end. Okay, some people don't like doing it because they think it's going to blow the dust into there. Personally, I can't see the problem, to be honest with you, because you're going to get dust anyway regardless in your Newtonian mirror. At some point dust will get there in your primary mirror. So don't be delusioned by you're not going to get dust completely. You will get dust from time to time. You can have the fan designed to go that way, so it's going to withdraw the air outwards. But however, it's not really effective, to be honest with you, and you need a high power fan to do it if you want to do it that way. It doesn't really matter how or which way you want to put your fan. Either way, both systems work really well. Okay, so to be honest with you, I prefer to have it so my fan is going to blow inwards into the tube. So what we're going to do is we're going to place the screws in there, line it to the holes. Okay, using a small screwdriver to get through between the fan. Again, this just depends on your fan system. Okay, so we're going to line up the screws. So once you've got all 4 screws lined up, okay, it's looking already professional. Okay, so it's looking pretty smart now. I'm going to show you how to wire up the circuit. And the good thing about this device is I've designed it in a way so you don't need to do any soldering. Okay, no electrical soldering, no mathematics to work it out. Okay, this is all worked out. I've worked it all out and it should work. Okay, perfectly. Alright, I've done a bit of Ohm's law to work out so it's not going to blow any circuitry and all that. And to be honest, it's pretty safe. Alright, we're only drawing 5 volts and we're only using, you know, less than 1 amp. Okay, so it's not a lot of power. Okay, we're dealing with. Basically, with this, I've got my speed controller. Usually, when you buy this set, usually it comes with this harness. As you can see, I have taped or I've zip tied my harness because it's quite a long cable. Now, to be honest with you, if you're really good with electrics, you can cut these cables off and shorten the length. Personally, I've gone a bit lazy. I just wanted to make this video guide a little bit easier for some people. Basically, this cable reaches about 50 centimeters long. Okay, so I basically just zip tied it, folded away what I needed. Okay, because basically what this is going to do, this harness is going to fit inside my project box. Okay, so it's going to be stored away neat and tidy. Now you can cut it down if you wish. Cut it down. Just make sure you connect it all together. So if you don't want to do that, then that's fine. Now the project box is a little bit smaller than I expected, and it is a bit of a tight fit to get it all in. Okay, it is going to be difficult to put it in place, but I've got it all arranged so I can get all my components inside that box. Again, I've just drilled in the 2mm holes so I can line up my box here and mount it with screws here. Okay, but I'm not going to do that just yet, because what I do is I'm going to show you the basic circuit. Again, this is me speed controller, and the beauty about this one is all the connections, you can't go wrong. They're all lined up. Line up the connections where the lines are. Okay, that is that part there. Okay, so you got that part there, and then we have the USB 2 to 3-pin converter. Okay, this will simply just clip onto the male end of the 3-pin. Okay, like so, and it clips in like so. And then afterwards, you've got a female connection here and this is basically for the fan. Just be careful because some of the pins are quite delicate, so you just want to line up the pins like so. Okay, that's clipped in like that. That is basically your circuit. Okay, there's no need to go any further. Okay, that is basically your circuit. See how easy it is to assemble. There's no need to do any soldering whatsoever. So I'm going to fix my storage bay, my project box in so. Okay, that's the bottom half. I'm going to put all my wires in there. So, after a lot of fiddling around and getting that wiring loom into that box, basically now it's all sealed up. Now this project box is a little bit small, but on my specifications I've upgraded, I've reannotated the details for a slightly bigger box. Okay, so if you're wanting to do this if you want to do this project yourself, just order a slightly bigger box than this. But also I've rewired it, I managed to get it all in there and it's all sealed up and tight. Okay, so it's not going to let loose. I have a little bit of a wire here, but that's okay, it's firmly fixed. The good thing about the speed controller, peel off the adhesive backing and we're going to fix the speed controller just there. Okay, that's all it is. Okay, we're going to fix the box. Okay, that's going nowhere. Okay, so that's now fixed in place. We'll fit the finger guard in like so. I'm just going to line up these screws here. Okay. Okay. That is now the whole assembly assembled. Now the good thing is we can use the 3 meter male female end USB. So we're going to check, see if it all works first before we go any further. Connect the female end and then using the adapter connect it to the 1 amp adapter. Okay, the 1 amp output. Okay, so that's in place. So now we're going to fit this 3 meter cable. Okay, and as you can see, it's all working. This is the lowest speed at the moment, and as you can hear it, it's very quiet. That's exactly what you want. You want a nice quiet fan. And with the speed controller, you can just adjust the speed. That's it on maximum RPMs. I can feel the colour here, and that's what I want. So that's a good thing about this system. It's easy to fit, and I have an adjustable speed, so I can adjust the speed where I want it. Okay, and get the right setting. Now I've not installed a switch. There's no real need to, because believe it or not, the USB acts like a switch. So you disconnect it if you want to switch it off. Okay, so there's no need to install a switch. Okay, this is my speed control, and that's basically the whole setup running. So now what we're going to do is we're going to fit the velcros, and we're going to fit it at the back of my Newtonian reflector. Now as you can see, now I've fitted the Newtonian cooler. Basically this is what I meant. You know, I want a bit of a ridge so that I can just start peeling back, and already that velcro is pretty strong. Okay, so that's the reason why I wanted a bit of a lip, so I can just lever this out. As you can see, that is strong as hell. Okay, so and it's very difficult to try and remove it. So that's why I needed a bit of a lip, so I can push it out like so. Okay, and as you can see, you only need a little bit of Velcro. You don't need too much, and that is really strong. Okay, that's not going anywhere. All right, and that's all you need. A little bit of the 20mm Velcro, and you just basically just connect it up. Okay, it's quite easy to fit. Okay, and again, you just fit it anywhere you want. Okay, depending on where your eyepiece holder is. Okay, you can fit it absolutely everywhere. Okay, so again, it just fits in snugly like so, and that's going nowhere. Alright, that is rock solid. Okay, really rigid. We test it out, making sure it's okay with the lead. Alright, and as you can see, that looks pretty smart. Okay, and what that'll do is now we'll blow all the cold air into the tube, cool down the optics, and then stabilize the view. Okay, so it will, and even when you're not viewing, okay, you can switch it off. You'll probably notice that even with this switched off, you can actually see more air currents if you switch the power off. So usually if I put it on the lowest setting, on quiet setting, that will help to maintain and stabilize your views. Okay, so with that, the lowest setting, the lowest speed going, okay, this will enable your optics of your Newtonian to be at its peak performance. Providing you collimate your Newtonian, and the Newtonian will not perform to its specifications if it's not collimated. And 80% of the time, usually the optics are very good. If they're not collimated, then they'll need collimating. So when you start your observe session, make sure you collimate your optics. The 20% is usually determining how cold your optics are, or they are cooled down enough. Okay, this will help to improve on the Newtonian. So all your images of the planets and the moon will be greatly enhanced, okay, once they are cooled down. The other 10% is, like always, like most astronomers will fear, is it just depends on how good your skies are. If the Earth's atmosphere is turbulent, then there's nothing you can do about it. It's just the way it is. But this little cool device will help enhance your Newtonian to perform to its peak performance. And believe me, it is a fantastic. It's cheap to make. You can make it yourself. It's all you need really to do this modification. But as you can see, it looks professional. It looks like as if it's part of the Newtonian itself. Good thing is, it acts like a light shroud, so it'll protect it from the elements. So now you know how to make one. Please undertake this. I seriously highly recommend that you do. Again, we're also available on this link. Okay, we're also available on the Facebook group, Astronomy for Beginners. Again, we've got a lot of good advice. If you want to seek anything with help with all our members, please feel free to click on there and visit us on Facebook. And again, if you like my videos, please feel free to comment in the video. Please subscribe, click on the subscribe button, and look forward to another video guide. And thanks for watching, and clear skies to you all.